In this tutorial, we're going to look at how to use Grasshopper, which is a plugin that runs on top of Rhino, to create a parametric facade, which we can control through dynamic inputs to specify the resolution of the facade, and also some of the geometry of the facade, such as the opening size and the depth that it's extruded. The geometry of the facade will also be dynamically referenced to Rhino geometry. So here we have it based on a surface. If we change the shape of that surface, the facade will respond dynamically to that shape. So I'm going to close Rhino and start a new blank Rhino document. I'm going to launch Grasshopper by typing Grasshopper into the command, and it'll launch a window like this. And what I like to do when I'm working with Grasshopper is to actually dock the Grasshopper window on the right side and the Rhino window on the left side, so I can see both at the same time. So Grasshopper is still an external plugin for Rhino, so if you haven't installed it yet, you're going to need to go online and look for Rhino Grasshopper. And here you can find Grasshopper's website, which should give you a link to the download of the current version of Grasshopper. But if you're using the lab computers, Grasshopper should already be installed for you. So here you can see the basic Grasshopper interface. It's pretty simple because it's made to be an addition on top of Rhino. So it's a basic menu structure which gives you access to some of Grasshopper's features. The main component of the interface that you'll use are these docking menus, which cluster all of the functionality of Grasshopper within individual nodes. So these are organized similarly to how you'll find commands organized in Rhino, but they include a lot of additional features such as working with parameters, different kind of math operations, and operations with data sets that we'll get into later. So when you first install and open Grasshopper, you'll actually have only 9 of these docs available. These 9 are the basic components within the basic Grasshopper installation. But what's great about Grasshopper, and the reason it's become so popular in recent years, is that it's actually very easy for people to extend and add new functionalities. So all of these extra tabs that I have here are just extra libraries that I've installed for Grasshopper, which actually give me new features and new ways to work with Grasshopper and Rhino. So for instance, I have the Kangaroo library here, which allows me to do physical simulations. I have Weaverbird, which allows me to work with meshes and subdivision surfaces, as well as Human, which does a lot of interface work, and Karamba, which actually lets you do structural analysis in Grasshopper. So for advanced uses of Grasshopper, you might need to install one of these libraries, but for the purposes of this tutorial, we're just going to work with the basic functionality of Grasshopper. So to start building the wall, I'm actually going to define some base geometry in the Rhino model that we will base our facade off of. So first I'm going to draw a simple curve. I have the curve start at the origin and go out 0 units. So my model right now, you can see, is in meters. Now I'm going to rebuild this curve using the rebuild command. I'm going to rebuild it with 3 points and degree 2 curvature. Hit OK. So now if I hit F10, you see I have 3 control points. I can just drag out that middle point to give the facade a bit of curvature. So now that I have this curve, I'm going to start to build geometry within Grasshopper to create the facade based on this curve. So the first thing I need to do is actually create a node within the Grasshopper interface that will pull in this curve and reference it from Rhino. To do that, I can use these geometry nodes here, which have all the basic kinds of data and geometry that Grasshopper supports. Here you find the one labeled curve, so I can do this. Or if you want to just import any kind of geometry, there's a general geometry node here. So if I click on that icon, and I can click to place that geometry node onto my canvas. So these geometry nodes you can think of as empty containers, which will store information from our Rhino model. To reference the curve into this node, I can right-click on it. This will give me a context menu, which will give me some of the options for that node. A lot of these options are shared by the nodes, but there's some specific ones for specific node types. In this case, I want to reference one geometry, so I click on Set One Geometry. This will execute a command in Rhino and switch over to the Rhino interface with this special white arrow. This will let me reference geometry from the Rhino interface. So I'll click on this curve. It switches back to Grasshopper. Now you can see the nodes turn white, and this is a default visualization. This means that the node is operating correctly. Before, you remember, it was orange, which means that there's no data there. Also, if you have an error, the node will actually turn red. Now you see what else happened. This curve is still in Rhino, but now I have this red curve visualized over it. The red geometry is actually a visualization of the geometry that's in Grasshopper. So I can still select this curve. It's still an object in Rhino. I can move it, but you see that the reference, the red geometry, actually moves with it as well. Now if I select the node in Grasshopper, it turns green, and the geometry that's contained within that node or within that container turns green as well. So this lets you visualize different parts of the Grasshopper geometry. So first thing I'm going to do is actually extrude that curve in the Z direction to create the surface that my facade will be based on. To do that, I'm going to go into my Surfaces tab, and under Freeform, pick the Extrude command. So you notice when I hover over the icons, it gives me the name of the command and also a description of what the command or node does. This is a great way to explore all the functionality of Grasshopper. You can go around and look at all these commands and see what they do and try them out in the interface. In this case, I'm using the basic extrude, which will take in a curve and extrude it along a vector. So when I put this node into my interface, you see that the node has its name here, and it also has a set of connection points on the left side and a connection node on the right side. And the connections on the inside are known as inputs. This is what the function or the node is expecting to be input in order to do what it's supposed to do. So in this case, the extrude function expects a curve and a direction along which to extrude that curve. And if we hover over these inputs, we see that it's expecting a geometry of type curve, and under D, it's expecting a vector, which is the direction of the extrusion. So the way that Grasshopper works is it's basically a flow of data along these nodes. So we have the geometry of a curve stored in this node here, and this node is expecting a curve to be input to do the extrude operation. We can simply connect this curve node here by clicking on its output and dragging to the input of the extrude function. Once we hover over an input, we see that the line turns green, which means a connection is possible. We can release the left mouse button, and now that's connected. And this geometry, which contains our reference curve, is flowing into this input. And now you can see that the reference plane or curve is represented here as well. So you can always get feedback about what's stored in these inputs and outputs by hovering your mouse over the names. You see that our extrude node is still orange. This is because it's still awaiting some kind of inputs. You can also see that warning if you hover over the orange callout in the upper right corner. And in this case, the warning is that the parameter D is still waiting to collect data. So the D parameter specifies the direction along which we're going to do the extrusion. If we do an extrusion in Rhino, just by doing the extrude command, you see that it's really using the same two inputs. We have a curve that we started with, but in this case it's assuming the direction we want to extrude into, but we can always set that direction manually as well. In Grasshopper, everything always needs to be specified exactly. Grasshopper is not actually going to make any assumptions about which direction or which data you want to work with. So to specify this direction, if we want to extrude in the Z direction, we can use a Z unit vector. So under the vector tabs in the vector category, there are these unit vectors, which will give you a basic vector of unit 1 in the different Cartesian directions. When you start creating nodes in Grasshopper, there's two ways to do it. You can basically select it from the icon bar above, or a shortcut is you can actually double click anywhere in the canvas. You can start typing the name of the node you want, and it's going to come up with a search list of nodes. So in this case, if we double click on the canvas and type in Z, unit Z is going to be the first result here, and we can select it and it'll place it directly into our canvas. This is a very quick way to work with Grasshopper as well. So now that we have this Z node, I'm going to plug that into the D input for direction. You can see that now we have an extrusion surface, which is taking that curve and extruding it into the Z direction 1 unit, in this case 1 meter up. If we click on the extrude node, that surface turns green because the surface is actually being stored in this node. Meanwhile, our curve is still being stored within this geometry node. So in Grasshopper, everything we do flows through these nodes, and all the geometry is active all the time. If we don't want to see a certain geometry, for instance, if we don't want to see this extrusion surface here, we can right-click on the node and just toggle preview to off. So right now, preview selected, we can click it and deselect it, and now we have the same geometry here. We can see our curve. So right now it's extruding the default 1 meter in the Z direction, but the Z unit vector also contains a factor input, which allows us to specify the length of that vector, or in this case, the amount that the curve will extrude in the Z direction. So to set that input, Grasshopper comes with a variety of different input types that you can get through the parameters input tab. And the most common one is a number slider. So I can click the slider and create one here. It creates a basic slider that allows us to drag the circle to specify a number between 0 and 1. If you want to create a different range, you can double click on the node. It will pop up this slider interface, which allows us to specify whether we want to work with integers or real numbers, also the minimum and the maximum value, and then the current value of the slider. So here I'm setting the minimum to 0, the maximum to 10, and then I'll set it to 5. And then I can connect the slider to the factor input on the Z vector node. And now that factor is set to 5, and it's extruding 5 units or 5 meters in the Z direction. Now I can dynamically change the value of that slider, and my extrusion responds according to that value.